Hello everyone, welcome back to Competition Guru, and today we will study about the aromaticity, and I am teaching this topic for the particularly IIT JAM students. Means from the topic of the view is for the particularly IIT JAM students, and it is also beneficial for the +1 and +2 students because aromaticity and the different aromatic compounds are of the much importance for the also IIT and also our PG students. Okay, so basically this concept aromaticity is related to the mostly organic compounds, and if we will see about the aromatic character, then first of all the picture came in our mind is benzene, because this compound is very much famous for the aromaticity. So why it is aromatic and why we call this aromatic? So first of all we will discuss that why these particular compounds or a category of compounds have been called as the aromatic compounds, because the compounds which are aromatic, they all have the same aroma. Aroma means they have a particular kind of smell. That's why all those compound which are classified as aromatic compound having particular aroma. That's why we call them as aromatic compound. And we see this compound which is benzene, it is your aromatic compound, and aromaticity means stability. So a compound which is aromatic means that is very much stable and it has resonance energy is equal to 36 kilojoule per mole. It means which is having greatest energy among all other aromatic compounds. If I will give you the list, first of all, just see the list. As number 1 is here benzene, which is top most aromatic compound, means it is very much stable as compared to other aromatic compound. We will study what is aromaticity and how we'll find the compounds are whether aromatic or not. Then we have pyridine, then we have thiophene, then we have pyrrole, and we have purine. Now, as it is clear that benzene is two most aromatic as compared to all other. These all are the example of aromatic compound. How we know? We will study the different aspects or we will study the different condition for the aromaticity, but as I am telling you in a simple way in the form of resonance energy which is describing the stability of the compound, then I can say that this is 36 kilojoule, its value is 32 kilojoule per mole. Okay, its value is 26, its value is 21, and its value is 16. Once again units are same, kilojoule per mole, and kilojoule per mole. So as you can see from the data that benzene has the highest resonance energy. So a compound having highest resonance energy is said to be more stable. So it is the highest aromatic also and it is highest stable also. Now we will study one by one what are the aromatic compounds, what are anti-aromatic compounds, and what are non-aromatic compounds. So first of all, let's start with the aromatic compounds. Okay, so first condition, the compound must be cyclic. The compound must be cyclic, number 1. Second, each atom should be sp2 hybridized. Why sp2 hybridization is needed? Because we need trigonal planar geometry, or you can say that all atoms should be in same plane. First of all, as we know that benzene is the aromatic compound, so you can see that it is the example of cyclic compound. Also you can see that each carbon having the hybridization sp2. sp2 means geometry is trigonal planar, means all the carbon atom of the benzene are in the same plane. And why we need them to be in the plane? Let's discuss that also, which is your third condition. Conjugation must be followed, or simply you can say delocalization of the electrons. Means these pi electrons are not localized, these can be delocalized. So as benzene is following the condition of the conjugation, and we know that for a conjugation we need all the atoms should be in the same plane so that proper conjugation takes place. As we can see in the next slide, as I will draw here benzene, and we have different p orbital of the carbon atom. Now we can clearly see here like the pi electron conjugation, means pi electrons are delocalizing here in these orbitals, and they all having the equal contribution of the pi electron. So now we will go further for the another condition. So what is the next condition after the conjugation? So next condition is here, the compound must follow Huckel rule. Now Huckel is a scientist, and what he said that for an aromatic compound, the compound should have 4n plus 2 pi electron, where n can have a value of 0, 1, 2, 3. Now if we will put the value of n is equal to 0, then what we get? 2 pi electron. If we put the value of n is equal to 1, then we get 4 plus 2 is equal to 6 pi electron. If we put the n value 2, then we get 10 pi electron. If we put the value of 3, then we get 14 pi electrons. So if a compound having 2 pi electron, 6 pi electron, 10 pi electron or 14 pi electron, then we will consider them as aromatic compound. Let's have some examples. First of all, this compound having, you can see here, two pi electron, which is fulfilling our condition. Now see here, 2 pi electron plus compound is cyclic plus conjugation plus each carbon is sp2 hybridized, because this carbon, which is your carbocation, is also having hybridization sp2, is also having hybridization sp2. Now next example we will take 6 pi electrons. The most famous example is benzene. Next example for 10 pi electron is your naphthalene. And for 14 pi electron, we have anthracene as the example. So these compounds follow all the 4 conditions, which are the compound must be cyclic, The compound must has sp2 hybridization. Every carbon or every atom should have sp2 hybridization, so that all atoms should be in the one plane, and another conjugation must be take place, and also they should follow 4n plus 2 pi electron system. Okay. Now see another examples. As you can see here, nitrogen, which is your pyridine ring. Okay. See here, 1, 2, 3, 3 pi bond means 6 pi electron, following 4n plus 2 pi rule, having cyclic structure. There is also delocalization, means conjugation of the electron, and also here all atoms having sp2 hybridized. Okay, so we can say here, now you have a one question in your mind that I will tell you with the example of pyrrole system. It is called pyrrole. Okay, this pyrrole is also aromatic, but according to you, here it has 2 pi electron, and here it has also 2 pi electrons. So how we will make 6 pi electron? Now this nitrogen has lone pair. So these lone pair will enter into the conjugation, and we have total electron 6 electron which are in the conjugation. That's why pyrrole system is also aromatic in nature. But come here, it is your pyrimidine. Okay, sorry, pyridine, not pyrimidine. In pyrimidine you have two nitrogen at 1 and 3 position. It is pyridine, which is having only one nitrogen atom in the cyclic ring. Now here its lone pair, so its lone pair is outside, and the position of the lone pair is such like that its plane is perpendicular to the other orbital which are taking place into the conjugation. It is not in the same plane. That's why these lone pair are not going in the conjugation. Okay, as we can say, one p orbital and another p orbital are in the perpendicular direction. As we know, we have 3p orbital, px, py and pz, and it is in the x-axis, y-axis, z-axis, all are in the different direction and perpendicular to each other. So this lone pair is your sp2 hybridized orbital, means this lone pair is present in the sp2 hybridized orbital, and these are the p orbital, na? Because pi bond formed by the use of the p orbital which are not hybridized, and they are from the different plane in which the lone pair is the present. Now we will have some another example, like you can see here thiophene. Now in thiophene also sulfur has lone pair, but it has two lone pair. Now one of its lone pair is in the conjugation with this ring, but this lone pair is in the different direction, or we can say that it is perpendicular to the plane in which the conjugation is taking place. So total there are 6 pi electron, hence thiophene is also aromatic compound. Now it is your furane ring. It has also two lone pairs, but one of the lone pair enter in the conjugation, but the another one is not. So due to total 6 pi electron, this furane system is also aromatic. Now the question arises, out of these three different aromatic compound, and also we call them as the heterocyclic compounds. If a compound having other element than carbon and hydrogen in the ring or in the open structure, then we call them as the heterocyclic compound. Okay, for the open chain it is different, but in the cyclic, as the name is heterocyclic. So if in the cyclic compound there is another element than carbon, like here is sulfur, nitrogen and here is oxygen, then we regard them as the heterocyclic compound. Now it is mostly seen as the topmost aromatic compound among these three, and it is greater aromatic as compared to other two one. Why? Because sulfur is less electronegative and its lone pair are easily in the conjugation. Now nitrogen is more electronegative than sulfur and it releases its lone pair with a small difficulty. And for oxygen, it becomes further more difficult. That's why its resonance energy is 16, it's 21 and it's around 26 to 28. Why? Because oxygen is topmost among the sulfur and nitrogen. So oxygen does not release its lone pair easily. That's why this your purine system is less aromatic as compared to others. Okay. Now more example of the aromatic compound. 2 pi electron, cyclic, conjugation takes place. Also these are the sp2 hybridized carbon each. So all are considered as the aromatic compound. Now we will study what are the anti-aromatic compounds. What are anti-aromatic compounds? Okay. In anti-aromatic compound, you will see all the condition. They have the similar, just like the aromatic compound. Only one condition is different, which is here the pi electron should be 4 and pi. Okay. Like number 1, cyclic. What is the cyclic? As I told you, if we have a compound like this, we will not consider it in the anti-aromatic compound because it is not your cyclic compound. Second, every atom should be sp2 hybridized. Third, conjugation should be takes place. And how many electrons should it have? It should have 4 n pi electron. Okay. So here n should be 1, 2, 3, 4. So how it's going on? If we take n is equal to 1, then 4 pi electron, 8 pi electron. Okay. If we take n is equal to 2, n is equal to 3 means 12 pi electron. N is equal to 4 means 16 pi electron. So if you all have different pi electron, then what will you do? You will do it like this. It is your cyclobutene. And what is this cyclobutene? It is cyclic. Each carbon is sp2 hybridized. It is having 4 pi electrons. Conjugation is also taking place. So it is the anti-aromatic. And it is example of the anti-aromatic compound. What is the another example? Cyclopentadiene, but this carbon must be carbocation, because if it is not the carbocation, then the compound will not be cyclic and the conjugation will not be proper. How? We will discuss later. As this, because as we know, it is the carbocation means sp2 hybridization, and one of the our prime condition is that the atom should be sp2 hybridized, so that all the atoms should be in the same plane, so that the proper conjugation takes place. Now, it is also example of the anti-aromatic compound, and these are the least stable among aromatic, anti-aromatic and non-aromatic. These are the compounds which are the least stable. They do not exist even at the room temperature. It dimerizes with the molecule just like it, and it forms this kind of compound. So, what we can do to remove or to stop its further dimerization? We can add here bulky group like tertiary butyl, and now this tertiary butyl kind of compound, due to the bulkiness, now it is rigid and it will undergo the steric hindrance and repulsion, and then it will not further dimerize with a molecule of just like. And now we will go further and do one more example. Like as we have a compound like this, okay, and we have a compound like this. Now it will also further go and we will get a compound like this, okay. Now next, as we have discussed the anti-aromatic compound, anti-aromatic means what it should be have, as we can see here like this. How many electron? 6 pi electron, and it is also your sp2 hybridized. So all the atoms are cyclic, number one. All the atoms are sp2 hybridized, 6 pi electron. So you can call it as the aromatic compound. And you have also studied anti-aromatic compound, which is the least stable among the. Now we will go for the non-aromatic compounds. Okay, what are the non-aromatic compounds? Total electrons are 8 pi electrons. So it is following the condition of the anti-aromaticity, cyclic sp2 hybridized 8 pi electron system, but its structure is like that and it is existing in the tub shape arrangement to avoid the repulsion among them, and all the atoms are not in the same plane, So if not all the atoms are in the same plane, no conjugation, no proper conjugation. So the compounds in which all atoms are not sp2 hybridized, all atoms are not in the same plane, then there is no proper conjugation, and those kind of compounds are called non-aromatic compound. We can take also the another example. Now this carbon is your sp3 hybridized. sp3 hybridized carbon having tetrahedral geometry. These all are the sp2 hybridized carbon. So sp2 hybridized carbon are planar, means all the atoms are in the same plane. But due to this carbon, the conjugation is not proper. Conjugation is not proper. As the conjugation is not proper, then this compound is not aromatic compound and it comes under the category of the non-aromatic compound. Now next we will see, if we have a compound like this and we have a negative charge here, then how many total electrons? 6 pi electrons. Then we consider it under the category of aromatic compound. If we have here positive charge, then total 4 pi electron system, it comes under the category of the anti-aromatic compound. And if it comes under this category, here one atom is sp3 hybridized, then non-planarity in the molecule, and it is called non-aromatic. But non-aromatic compounds are still stable as compared to anti-aromatic compounds. So in terms of stability, we will say aromatic are first in terms of stability, then your non-aromatic compound, and then your anti-aromatic compound. Now I will give you one of the most interesting example. If we have some alkene like this, and if we will add Br2, then we get a addition compound like this. But addition reactions cannot take place in the benzene ring because it leads to disturb their aromaticity, and aromaticity means stability, so we can't disturb the stability of any compound. If you will add here, then it is not possible because this compound is not your aromatic compound. So what we can do? We can do here the electrophilic aromatic substitution reaction, or we can say aromatic electrophilic substitution reaction, in which once the bromine atom is here, okay, then what will happen? You can see here H, this will come here, it will go, and we get a compound like this, bromobenzene. Okay, or further we will discuss in the detail about the electrophilic substitution reaction. Then I will tell you particularly how the bromobenzene forms, because here it break like this, and then this electrophile will substitute here in the benzene, and this Br negative will abstract the hydrogen atom from one of the position from the carbon atom, and then the further the substitution of the Br as a electrophile takes place. So aromaticity is one of the important property, and I will tell you one more example. If I have a compound like this and I get here CF3, 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 and here we can also write CF3, okay, but here H should be also present in order to pull the valency of the carbon, and here we have a compound like CH3, 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 and here we can say CH3, and there should be H present. Question often comes as the acidity. Which compound is mostly acidic? Acid means which releases H plus ion. If here H plus ion releases, then we get here what? You can write here negative and negative. Now 1, 2, 3, total 6 pi electron. Here also 6 pi electron, so it is following Huckel rule. So these compounds are highly acidic because these releases H plus ion as faster, because as the H plus ion releases, then this system will undergo conjugation and it leads to the formation of the aromatic compounds, and aromaticity means stability. And out of these two, if we want to compare, then we will say that this compound is more stable due to the presence of these fluorine, because fluorine means minus I effect. So as soon as this negative charge will exert here, means this negative charge is stabilized by the inductive effect of these fluorine atoms. And here we have CH3 group, which is electron donating group. So these electron donating group will intensify this charge and makes it unstable. So this compound is least acidic as compared to this compound. So aromaticity helps us to find the different property or application of the compound if we want to find them as which one of is the most acidic. So today we will discuss about the aromatic compound, anti-aromatic compound, and non-aromatic compound. Hope you like the lecture, and I hope all the doubts have been cleared about this topic, and now you will never forget about the aromatic, anti-aromatic, and the non-aromatic compounds. So we will have the same lectures for the IIT JAM and the other classes also. So if you have any inquiry or you want to take these sessions, then here is the number and you can contact on the same number. Thank you so much.